In our previous video, we introduced the topics of ATPG and pattern simulation. In this video, we are going to discuss three important terms: yield, fault coverage, and test coverage. These are essential concepts in DFT, and it's crucial to understand them before moving on to advanced topics. I recommend watching the previous videos to fully grasp this one. Hello folks, this is Ankit and I'm passionate about bridging the gap between technology and understanding. With a background in DFT, I create this channel to help engineers, students and tech enthusiasts navigate the intricate world of DFT. I'll explain DFT, which is a crucial part of chip design, in the simplified way possible. I'll cover all theoretical and technical concepts, and we will also discuss a lot of problems and issues faced by DFT engineers and explain their solutions in the most simplified way. What is yield in DFT? Yield in DFT refers to the percentage of manufactured chips that function correctly after fabrication and testing. It is a critical metric in semiconductor manufacturing and directly impacts cost, production efficiency, and profitability. When chips are manufactured on a silicon wafer, there is always a possibility that some chips are defective while others are fault-free. The ratio of good chips to the total number of chips on the wafer is called yield. Achieving 100% yield has not been possible with the current technologies, so yield typically ranges between 0 and 1, where 0 means all chips are faulty and 1 means all chips are fault-free on a wafer. Now, moving to our second topic, what is fault coverage? Fault coverage is defined as the ratio of faults detected on a chip during testing to the total number of possible faults on the chip. Our next topic is test coverage. So, what is test coverage? Test coverage is defined as the ratio of faults detected on a chip during testing to the total number of testable faults on the chip. To understand fault coverage and test coverage more clearly, we first need to understand one more term: fault simulation. What is fault simulation? Fault simulation is a crucial step in DFT used to evaluate the effectiveness of test patterns in detecting faults in a digital circuit. It helps in determining fault coverage, optimizing test patterns, and improving test efficiency. Fault simulation is performed before the chip is physically manufactured. At this stage, the chip exists only in Verilog code form, and therefore there are no manufacturing defects. Then how do we test faults before manufacturing? For that, we use DFT tools that virtually inject faults into the chip design. All ATPG tools have this capability. They analyze the design, which includes both sequential and combination logic, and inject fault at pin nodes. We can specify which fault types to inject, such as stuck at, transition delay, IDDQ faults, etc., using ATPG tools. This process is known as fault simulation. Key points for fault simulation: it simulates faulty version of the circuit by injecting faults. Example: stuck at faults, transition faults, bridging faults. It applies test patterns to detect these faults. And the last, it measures fault coverage by determining how many faults are detected out of the total possible faults. Let's understand fault coverage and test coverage with this figure. After injecting faults into the chip, we generate pattern to detect those faults. This process is called fault simulation, as discussed earlier. Now, one important point to note is that while detecting faults with the test pattern, we will categorize faults into two categories. First is testable faults, which can be detected. Second is untestable faults. which cannot be detected. Depending upon the number of testables and untestable faults, we calculate fault coverage and test coverage. Let's say the total number of faults detected on the chip is X. Using this formula for the fault coverage, that is, fault coverage is equal to number of faults detected to the total number of faults on the chip. The total number of faults will be the sum of testable faults and untestable faults. For example, if there are 3 untestable faults and 5 testable faults, the total faults will be their sum, which is 8. So, fault coverage will be X by 8. Now, to calculate test coverage, and we know the formula of test coverage, that is number of faults detected to the total number of testable faults. So, here testable faults are 5. So, test coverage will be X by 5. In real scenario, the number of faults and patterns is extremely large. Since the total fault count is always greater than the number of testable faults, we can conclude from the formula that fault coverage is always less than or equal to test coverage. This is a very important relationship between test coverage and fault coverage and is often asked in interviews. Note for this video. In the video working of scan chain, we have seen scan flops help us to detect faults more effectively, which gives points as mentioned here. Coverage on a chip will depend upon number of scan flops in design. Second point is scan flop able to control functional design. This is done by sending pattern from SI pin. Third point is scan flops help us to observe the behavior of the design during capture mode. So these 3 points play a major role in deciding the coverage of a chip. Moving further, more test coverage means good DFT has been done on a chip. In actual scenario, as an DFT engineer, when you will do ATPG, after pattern generation gets completed, you will see number of test patterns that get generated and test coverage percentage. More percentage means good DFT has been enabled on the chip. That is, maximum faults can be tested, and depending upon the number of faults on that physical chip, you can decide whether to throw or to keep the chip. And that is the major point of doing DFT. So that's the end of video. So far we have discussed about topics: fault coverage, test coverage, fault simulation and yield analysis. In the upcoming videos we will discuss how to do coverage analysis and how can we increase test coverage, what is test coverage for SA and TD faults, and why SA coverage is always more than TD coverage. All these questions we are going to discuss in the upcoming videos. I hope you find this video helpful. Please give your feedback and valuable suggestions. Thank you.